The sun is not going to last forever, and for 8 full minutes after it dies, you will have absolutely no idea. That is not a metaphor. That is physics. The moment the sun vanishes, light already fired from its surface continues racing toward us at 186,000 miles per second. 8 minutes and 20 seconds of the sky looking completely normal. The birds still singing, your coffee still warm, the shadows still falling exactly where they always do. And then, at 8 minutes 20 seconds, a wall of darkness hits Earth. Not sunset, not a cloud rolling in. Total, permanent, absolute night. No warning, no fade. The sky just dies. But here is the thing, by the time the light cuts out, everything has already changed. Something none of us would notice, something invisible, something operating at the speed of light, has already been erased, and its absence will send this planet hurtling into the void. That is what gravity does when it disappears. It does not leave slowly, it does not give you time to adjust. According to Einstein's general theory of relativity, gravitational influence propagates at the exact same speed as light, so the moment the sun disappears, the gravitational signal, the invisible tether holding Earth in its orbit, begins racing outward at 186,000 miles per second. It reaches Earth at the same instant the last photon does. 8 minutes 20 seconds. That is all we get. For those 8 minutes, something remarkable is happening. Earth is still orbiting a star that no longer exists. Think about that. The planet is still curving through space, following the path dictated by a gravitational field that has already ceased to be. The math still works. The forces still balance. For those few minutes, we are orbiting a ghost, and then the signal arrives. At 8 minutes and 20 seconds past the moment of disappearance, two things happen simultaneously. Every photon of sunlight in transit reaches its final destination. The last gasp of light scatters across the upper atmosphere and goes dark, and the gravitational wavefront reaches Earth, carrying the news that the sun is gone. In that exact instant, Earth stops curving. It straightens out. Physics gives it a new trajectory, not an orbit, not a circle, but a straight line punching outward into interstellar space at approximately 67,000 miles per hour. The planet does not slow down. It does not spiral. It simply releases from the curve like a stone let go from a sling. Earth becomes a bullet fired into the dark. The moon comes with us. Bound by its own gravitational relationship with Earth, independent of the sun, it continues circling our planet even as we drift into the void. The Earth-Moon system, this double world we have always called home, becomes a rogue binary pair tumbling through the Milky Way. Two rocks and all their passengers cut loose in the most silent darkness imaginable. But the darkness is only the beginning. Here is what the surface of Earth looks like in the first hour after the sun vanishes. The cities still glow. Artificial light, street lamps, screens, the orange wash of civilization still burning across the continents. On the daylight side of the planet, where sunlight was still flooding the surface at the moment of disappearance, the transition is instant and violent. Full sun to absolute black in a fraction of a second. No twilight, no dusk, just a wall of nothing dropping from the sky. On the night side, no one notices at first. Darkness was already there. But the cold has already started. Earth's surface temperature, the average, comfortable 59 degrees Fahrenheit that makes this planet livable, is maintained almost entirely by solar radiation. A small amount comes from Earth's own interior, from the radioactive decay happening in the planet's core and mantle. But that contribution is minor. It keeps the deep rock warm. It does not heat the air. Without the sun, the surface begins radiating its stored heat outward into space. And it does not stop. There is no input to balance the loss. The planet starts bleeding warmth at a rate of roughly 36 degrees Fahrenheit every 24 hours in the early days. By the end of the first full day, the surface has already dropped toward freezing across most of the northern hemisphere. Ponds and shallow lakes begin icing over. Crops already in the field begin to die. Animals that depend on temperature cues for survival start acting strangely. Circadian rhythms thrown into confusion by a night that never ends. Within a week, the global average surface temperature has dropped below 0 degrees Fahrenheit. Antarctica was already colder. Now the entire planet is catching up to Antarctica. Snow falls on the equator. Tropical forests, packed with moisture, begin to freeze solid from the outer canopy inward. The Amazon, the Congo, the rainforests of Southeast Asia, they do not die quickly. They suffocate slowly, layer by layer, as the cold drives down through the canopy and kills what the darkness alone could not. This is where the food chain starts to die. Photosynthesis, the process that sits at the base of almost every food web on the surface of this planet, requires light. Without light, it shuts off immediately, not gradually, immediately. The moment the sun vanishes, every plant on Earth stops producing oxygen and glucose. Green leaves hang in the darkness, their chemical machinery idle, waiting for a signal that will never come again. The fast-growing crops go first. Wheat, corn, rice. The staple foods feeding 8 billion people begin to die within days. Larger trees, oaks, redwoods, sequoias, carry enough stored energy in their tissue to persist for weeks, maybe months. But they too are running on reserves, and the cold accelerating through the atmosphere means they do not get the time their biology assumed. Within a month, vast stretches of vegetation lie frozen and dead. Herbivores begin to starve almost immediately. The cattle, the deer, the insects and the pollinators, the entire middle tier of every food web, the creatures that convert plant matter into animal tissue, collapses first. And when the herbivores go, the carnivores follow, not in weeks, in months. The cascade is slow enough to watch and fast enough that nothing stops it. Within a year, if a single year without the sun can be meaningfully measured any longer, the average surface temperature of Earth has dropped to negative 100 degrees Fahrenheit, colder than anything recorded naturally on Earth's surface, colder than a winter night on Mars. Small lakes and rivers have been frozen solid for months. The oceans, enormous heat reservoirs that they are, resist much longer, their sheer mass of water holding warmth for years, possibly decades. But even the oceans are cooling. Ice sheets spreading from the poles have begun crossing into what used to be temperate waters. At negative 109 degrees Fahrenheit, something eerie starts happening in the atmosphere. Carbon dioxide, the same gas we exhale, the same gas plants once breathed, begins to solidify. It falls as snow. Dry ice, raining down from a frozen sky, settling across a planet already buried under conventional ice. The atmosphere itself is beginning to condense. At this point, roughly 8 months in, the air is growing thinner, and the worst is still ahead. Around day 503, just under 17 months after the disappearance, the oxygen in the atmosphere begins to liquefy. This is not a metaphor. The temperature has dropped so low that O2, the gas that made complex life possible on this planet, transitions from gas to liquid and puddles on the surface of the ice. There is still enough oxygen in the atmosphere to breathe for a long time after this begins, because the process is not instantaneous across the entire atmospheric column. But the direction is irreversible. The air is dying along with everything else. The final equilibrium, the temperature at which Earth's residual geothermal heat exactly balances the heat the planet radiates into space, is somewhere around negative 381 degrees Fahrenheit. That is just 78 degrees above absolute zero. A temperature so cold that most of the atmosphere will have frozen onto the surface, layered in sheets of nitrogen ice, oxygen ice, and dry carbon dioxide. Earth will still be a planet. It will still be approximately the same size. But its surface will be as quiet and as dead as the surface of Pluto. Unless you know where to look. There are ecosystems on Earth that have never seen the sun. Not once, not in their entire evolutionary history. Right now, this moment, at the bottom of the Pacific Ocean, at depths exceeding 1.5 miles below the surface, living communities of organisms cluster around hydrothermal vents, cracks in the seafloor where tectonic heat drives superheated water, sometimes reaching 700 degrees Fahrenheit, up through mineral-rich chimneys into near-freezing ocean water. These vents do not need sunlight. They never did. At the base of these vent communities are chemosynthetic bacteria, microbes that convert hydrogen sulfide and other chemicals into energy the way plants convert sunlight into sugar. No light required, just chemistry, raw geological power turned directly into life. Sitting on top of these microbial mats, these living carpets of chemical-powered organisms, are tube worms over 6 feet long, yeti crabs covered in bristles that harvest bacteria directly from the water, Pompeii worms tolerating temperatures that would cook most animals alive, entire ecosystems thriving in conditions that would kill surface life in seconds. The sun disappearing does not touch them. Not immediately. Not for a very long time. The oceans are the largest heat reservoir on Earth. Even as the surface freezes solid, even as the atmosphere collapses, the deep ocean retains its temperature for decades, maybe longer. And the hydrothermal vents that power these communities are fueled by the planet's interior, by radioactive decay in the mantle and core that has been running for 4.5 billion years and will continue running for billions more. The sun's disappearance does not change what is happening in Earth's core. That engine keeps burning regardless, which means life continues. Down there in the dark, in the pressure, in the superheated chemical haze of ocean floor vents, life does not even notice the extinction event unfolding on the surface above. Bacteria reproducing in the zero-light chemistry of a volcanic seafloor crack, worms and crabs and alien-looking creatures conducting their lives at pressures that would crush a human being like paper. These organisms will outlast everything you have ever seen. They will outlast the freezing of the surface. They will outlast the collapse of the atmosphere. They may still be alive, in their quiet, lightless world, long after the last human memory of the sun has faded into nothing. But humans, what about us? The scenarios scientists take seriously are surprisingly stubborn. Geothermal energy, power generated from Earth's own interior heat, does not require sunlight either. Iceland already runs most of its grid on it. In a world without the sun, geothermal becomes not just practical but existential. Underground settlements, carved into volcanic rock, built around natural geothermal springs, sealed against the freezing surface above, could in theory sustain small human populations for extended periods. Nuclear power, which has nothing to do with the sun, provides another avenue. Reactors already in operation the moment the sun disappears would keep running for decades with the right fuel supply. The challenge is not just energy, it is food. Growing food without sunlight requires artificial light, which requires massive energy input. Hydroponics, algae farms under LED arrays powered by geothermal plants. Bacteria cultivated for protein, the same way deep ocean organisms built their food webs around chemical reactions instead of photosynthesis. The biology is possible. The engineering is brutal but not impossible. And all of this happens as Earth drifts silently through interstellar space, a rogue world carrying its passengers away from the sun's former position at 67,000 miles per hour. Within a few years, we would be past where Mars used to orbit. Within decades, past Jupiter. Within tens of thousands of years, we would be passing through the Oort cloud, the outermost shell of icy debris that still vaguely marks the boundary of what used to be our solar system. And then nothing. Open space. The gap between stars. The nearest star system, Alpha Centauri, sits 4.2 light-years away. Traveling at 67,000 miles per hour, it would take Earth approximately 18,000 years to reach it. No shortcut, no course correction, just momentum. A frozen world in the dark, moving through nothing, carrying the remnants of everything that ever lived on its surface. Here's what stays with me. Every ecosystem, every food chain, every agricultural system, every city and civilization on the surface of this planet is ultimately built on a single 93 million mile long thread of light. 8 minutes of travel time. That is the margin between everything you know and absolute darkness. We did not build civilization knowing this. We built it as if the sun were permanent, because for any timescale a human being can personally experience, it is. It is permanent enough. But nothing in this universe is actually permanent. Every star dies. Every orbit eventually breaks. Every source of light that has ever existed will one day go quiet. The sun has about 5 billion years left. That is longer than Earth has existed. But 5 billion years in a universe that has been running for 13.8 billion is not quite as comfortable as it sounds. So tell me in the comments, if you had 8 minutes of warning before the lights went out forever, what would you do? Is there one thing you would want to see or say before the sky went dark? I want to read your answers. If this left you staring out the window at the daylight in a new way, hit that like button and share it with someone who needs a reminder of how extraordinary ordinary sunlight actually is. Subscribe if you are not already, because next time we are going somewhere even stranger than a world without a star. The universe has rooms that make this look comfortable.